Hey, so good day, my dear STEM students. So for today, we'll be discussing all about limiting reactant. So before we proceed to our lesson, let us define first what is limiting reactant. So limiting reactant, in an ordinary chemical reaction, the limiting reagent is the reaction that indicates or determines the amount of product produced. So the limiting reactant is the substance that limits how much product will be produced during an ordinary chemical reaction. The remaining reactants are referred to as being the excess and become the leftover after the limiting reagent is completely consumed during the reaction. So this is the complete definition for the limiting reactant. So in our first example, in the Haber process, nitrogen gas reacts with oxygen or hydrogen gas to produce ammonia. How many grams of ammonia will be produced if we allow to react 50.0 grams of nitrogen gas to 50.0 grams of hydrogen gas during the process? So the first step is to write the balanced equation and determine the different mole ratio of that particular reaction. Okay, so this is the balanced equation. For every 1 mole of nitrogen gas reacts with 2 moles of hydrogen gas, it will produce 2 moles of ammonia. So this is the first step. Then step number 2, okay, step number 2, you have to calculate the moles of reactant. This time you will use the mass to mole stoichiometric calculations. Okay, so in the mass to mole stoichiometric calculations, you will use the amount of mass given dun sa worded problem, which is 50 grams nitrogen gas and 50 grams of hydrogen gas, and compute this to or convert this to the number of moles of these two substances. So since we are using mass to mole stoichiometric calculations, we will use the molar mass ratio of nitrogen. 28.0 grams nitrogen is the molar mass of nitrogen gas. Okay, so for every 1 mole of nitrogen gas, there is 28.0 grams nitrogen gas. And then you will cancel the unit of grams. Okay, always remember in any stoichiometric problem, when you see this particular unit, which is grams, ang kapartner nyo palagi is 1 mole of that substance. Kung ano man yung substance, water ba siya, nitrogen gas ba siya, or hydrogen gas ba siya, laging 1 mole yan. Di kayo maglalagay ng stoichiometric coefficient coming from the balanced equation kapag may nakalagay na grams. And you need to cancel the grams. Basta may grams, hindi kayo maglalagay ng any number aside from number 1. So that is 1 mole nitrogen gas, and you will get 1.74 moles of nitrogen gas. And then followed by hydrogen gas, cancel the unit. Then you will get 24.8 moles of hydrogen. So this is the mole value of the two reactants in your chemical equation. Then followed by step number 3. So you calculate the moles of the product produced, which is ammonia, to identify the limiting reactant using the calculated mole values from step 2 and the stoichiometric mole ratio from the balanced equation. This time you will use the mole to mole stoichiometric calculation. Since you will use the mole ratio, okay, so this is your balanced equation. So the mole ratio, ano lang yung kailangan natin? That is 1 mole of nitrogen gas, 3 moles of hydrogen gas, and 2 moles of ammonia. So ito yung gagamitin nyo in calculating for your dimensional analysis. So the computed value of mole for nitrogen gas is 1.74 moles of nitrogen gas. This value came from step 2. So the stoichiometric mole ratio is for every 2 moles of ammonia produced, there is 1 mole of ammonia reacted. So you cancel the number of moles, and then you will get 3.48 moles of ammonia. And then followed by the hydrogen gas, which is 24.8 moles hydrogen gas multiplied by the stoichiometric mole ratio coming from the balanced equation, which is for every 3 moles of hydrogen gas, there is 2 moles of ammonia produced. And then cancel the unit mole hydrogen gas, then you will get 16.5 moles of ammonia. Then take note, in writing your final answer. So, ang rule natin, kung ano yung starting amount, how many significant figures, ang starting amount. So, 1.74 has 3 significant figures. So, therefore, your final answer will be 3 significant figures also, which is 3.48 moles. Ganun din sa hydrogen gas, 24.8 has 3 significant figures, and then your final answer is 16.5 moles. Ammonia, which has 3 significant figures also. So from this step 3, you can now identify the limiting reactant. Okay? So the limiting reactant usually yung smallest computed mole value na nakuha ninyo. So comparing 3.48 moles of ammonia sa 16.5 moles of ammonia produced, so yung less is the one that you will going to choose. And what substance is the limiting reactant? Sino yung nag-limit to produce 3.48 moles of ammonia? And that is nitrogen gas. So therefore, nitrogen gas is your limiting reactant. Okay? And then the last step is to calculate how many grams of ammonia will be produced. Okay? So in step 4, since nitrogen gas is our limiting reactant, we will use the calculated mole value from step 3 to determine how many grams of ammonia will be actually produced during the Haber process. So you just simply rewrite yung computed mole value natin from step 3, which is 3.48 moles of ammonia, and then convert this mole of ammonia to mass of ammonia using the mole to mass stoichiometric calculations. Okay? So for every 17.0 grams ammonia, there is 1 mole of ammonia. So 17.0 grams ammonia is the molar mass of ammonia. So lagi natin tatandaan, basta may grams, ang lagi lang kapartner niyan is 1 mole of that particular substance, regardless kung nasa numerator ba siya o denominator. Depende kung ano yung kakancelin nyo or ano yung unwanted unit. So, in this particular example, the unwanted unit is mole of ammonia. So, therefore, yung 1 mole of ammonia ang nasa denominator to cancel the mole unit. And then, 3.48 times 17.0 grams, you will get 59.2 grams ammonia. So this is the mass produced during the Haber process. Okay? So in our final answer, we have 3 significant figures, 59.2. Our starting amount is 3.48. So ganyan yung paglalagay ng number of significant figures in writing for your final answer. Okay? So if there are any question, you just simply visit again or review this video lesson tutorial. Okay, thank you.